All right, we're covering two different sections today. We're covering 2.1 and 2.2. Spend a little bit of time on both of them. Probably a little bit more time. Well, I don't know. We'll just have to see how it works out. But 2.1 is comparing and ordering and rounding numbers. Okay? Obviously, we're talking about decimal and whole numbers both. Okay? Not just, decimals or not just whole numbers. So, open up your books, section 1. Okay? So we can look at some examples. All right. When we talk about rounding decimals and whole numbers. Okay? Talk about that. Step 1 is to identify the place value for the number you are given. Okay? So, for example, if I had the number 7.126 and they told me to round to the hundreds, okay? Well, to round to the hundreds, that would be that right there. Okay, it'd be the 2 right there. Okay, so you identify the place value, whether it's, sometimes they will say round the underlined digit. Okay, that's how they do it sometimes. That's how they did it last year in 6th grade. Sometimes they give you the actual number, round the 2. Okay, most of the time they're either going to say round the underlined digit, or they're going to say round to the nearest place value. Okay? What we basically need to know is this. So we need to, step 2, is mark the digit you are rounding to, that you're rounding, and then circle the number immediately to the right. Okay, so if we're rounding to the hundredths place value in our original problem, 7.126, okay, and they tell us to round to the hundredths place value, then I'm going to mark the hundredths place value with a little, what I call a caret, okay, and then I'm going to circle the number immediately to the right, which is the 6. Okay. Step 3, if the circled number is 5 or less, then leave the marked number the same. Okay? The second part of that is if the circled number is 5 or greater, then increase the marked number by 1. Okay, so in our case of 7.126, we mark that number, we circle the number to the right. The 6 is greater than 5. Okay, it's greater than 5. So therefore, I'm going to increase 2 by 1. So I'm going to have 2 plus 1, which is 3. So my new number is 7.13. Okay? We make that a 0, but since it's a decimal, that 0 is not needed. You don't need to have that on the end of the number. Okay? Now let me go back up here. I miswrote up here. This should be, go back up here where it says, if the circled number is less than 5, okay, leave the marked number the same. Okay, I misstated that a while ago. I was writing faster than I was thinking, or thinking faster than I was writing, one of the two. Okay, the final step then, all numbers to the right of the number you rounded to change to zeros. Okay, so that's the 4 steps there that you need to do. So let's do another example. Do it all at once instead of the different steps. If we wanted to round 32.01 to the nearest tenth, okay, 32.01 to the nearest tenth. All right, so if we were going to go to the nearest tenth, which digit is the tenths place value? Anybody remember? Which one is which number up there, or which digit up there is the tenths place value? Anthony?
1.
Do what?
1.
No, not the 1. Close. Vivica, 0. So this is my tenths place value right there. So I'm going to circle the number immediately to the right, which is a 1. 1 is less than 5. So what happens to the, and I copied that wrong. Hang on, that's supposed to be a 9. It's supposed to be a 9. I think my part of my 9 didn't show up. Okay, so let's rephrase it. It's a 9, so it's 5 or greater. So what happens to the 0? What do we do to it? We do what? Right, we add 1 to it. Well, when you add 1 to 0, it becomes 1. So 32.1. Now, everything to the right turns to zeros. But since it's at the end of the number on the decimal side, we don't have to put it. Okay, so our answer is 32.1. Okay, now real quickly, let's make sure we remember our place values on this side of the decimal, on the right side of the decimal. You have tenths, then you have hundredths, thousandths, okay, and then next is 10,000ths, then hundred thousandths. Okay? Tenths, hundredths, thousandths, 10,000ths, 100,000ths. Okay, that's your place values on the right side of the decimal. Okay, so remember that. So some of these you're going to have to do it. You're going to have to round it. Okay, so for example, if I wrote the number 7.0086, okay, and they wanted me to write that in word form. Okay, well, that written in word form is 7 and 86. What? What place value is the 6 in? Thousandths. So that's how you'd write that number in word form. Okay? The word and is for the decimal. You only put the word and in there if there's a decimal in the number. Okay, so I want you to write this one in word form. I'm not going to say it because it would be said in word form, and I don't want you just to copy what I say. I want you to write that one right there in word form. Mm-hmm. Yes. What do you get? 6 what? I just didn't hear it. You may have said it right. I didn't hear it. Yeah, 600ths. Yes. 78 and 600ths. Now, some people would put 6 100ths. That's fine. You don't have to. But some people want to identify it as the 100ths place value, the 10,000ths place value. They say stuff like that, which is obviously you need on the 10,000ths. But you don't have to have 6 100ths. Okay, it's just 600ths. Okay, same thing. You don't have to, but if you feel comfortable doing that, that's fine. All right, now, so that's rounding and writing them. Let's talk about comparing. Okay, let's talk about comparing them. Let's say I have 7.08 and 7.03. Okay, if I want to put an inequality sign, in the blank that would make the statement true. Okay, remember we have is greater than, is less than, okay, and obviously equal sign is not an inequality sign. So which sign is going to go in there? Is greater than or is less than? What? Greater than. Okay, remember, when you look at decimal numbers, think about money. Okay, which is larger, $7.08 or $7.03? Well, obviously, $7.08. Okay, it doesn't depend upon how many digits the numbers have. An example, if I had 0.6 and then I had 0.59237, okay, which one is greater? Huh? 0.6, yeah, obviously. 60 cents would be more than 59 cents plus some change. Obviously, there is no change. It equals 237 on this. Okay? The other way you can do it is stack them vertically and make them both have the same amount of digits. Okay? Well, if you do that, 60,000 is a lot larger than 59,000. Okay? So that's one way to compare them is make sure they have the same amount of digits. Okay? All right, what about this one? 25.024, 26.023. $25.024 and 26.023. Okay, which one's larger? Haley, Shields, which one's larger? Yes, 26.023. Okay, so we put the is less than sign in the blank. All right, now let's talk about ordering. Okay, not talking about what you do to your friends, ordering them around. Oh, nothing. Yeah. All right, now, ordering numbers from least to greatest. Okay, least to greatest. Let's say I have this, 1.2, 3.2, 0.2, and 0.9. Remember that 0.9 and 0.9 are the same. Okay, I always want to emphasize that because some people sometimes forget and they get confused. Okay, but they are the same. All right, now, so as we look at those numbers, which one is the smallest? Haley. Point what? Yes, 0.2. Okay, so 0.2 is the smallest. Okay, so what's the next smallest? Anthony? No, good guess, but no. Haley? 0.9. Remember, 20 cents and 90 cents. It'd be like $1.20. If you think of it in money terms, 1.2 is like $1.20. 0.9 would be like 90 cents. So which would you rather have, $1.20 or 90 cents? Okay. All right, so 1.2 would be next, and then 3.2. Okay, so that's least to greatest. The smallest number to the largest number. Okay, once again, if you make them all have the same amount of digits, you would have 0.2, 0.9, 1.2, and 3.2. Okay? So obviously a whole number with the decimal is larger than just a decimal number. Okay? So if you think of a number line, and here's 0, here's 1, 2, 3. So that's 1, 2, 3. Then 0.2 would be back here. 0.9 would be there. 1.2 would be here. Okay, and then 3.2 would be there. That's what it would look like on a number line. Okay. All right, do this one on your own. 0.86, 0.03, .91, and .2. Yeah, least to greatest. When you have the answer, raise your hand. Juliana. Yep. Okay, .03, .2, then what? No. So not .91, what would have to be next? We've used those two. Yeah. .86, .91. Okay? No, that's a decimal. Now, here's the other way to look at it, and this will help people sometimes. Obviously, yes, Juliana, if it had a 1 in front of the 1.86, then that would obviously be the larger one. If we write the numbers and make them all have the same amount of digits, okay? Okay, now, we've rewritten the numbers. They all have the same amount of digits. Now do this. Okay? Obviously, if the decimals aren't there, y'all know that 3, 20, 86, 91 would be the correct way to do it. Okay? But you got to make sure if you do that they have the same, all of them have the same amount of digits. Okay? Because if they don't, then it'll start getting confusing to you. In other words, if I just say .2 and then I erase the decimal, well, then that's 2, and you're going to think that it's smaller than 3. Okay? So you got to make sure they have the same amount of digits, but that may help you to get the decimal out of it and maybe confusing you. Okay? All right, so that's 2.1. Let's look at 2.2. And I'm covering 2 today. You're not going to have homework over, and we're going to do it in class tomorrow. So don't start panicking on me. Okay? All right, who can tell me when we're adding decimals, what's the thing you have to do? Anybody remember? What? We have to line them up. What do we line up? The numbers, what? The decimal. Okay, good. So you get 15.8 plus 7.6. Okay, you got to list those vertically and line up the decimal. Okay? So the decimal here has got to be lined up. All right, now, when we add it together, that gives me a 4. 6 plus 8 is 14. Carry my 1. 1 plus 5 is 6 plus 7. Be 13. Carry my 1. 1 plus 1 is 2. Now, you just bring the decimal down into your answer. So that gives you 23.4. Yes, when you're adding, you always have to line up the decimals. Adding or subtracting, either one. Okay. The other thing you need to do is make sure all numbers have the same amount of decimals place values. I'll show you an example of that in just a second. Okay, so those are the two things you really got to pay attention to when you're adding or subtracting. You must always line up the decimals, and you got to make sure all numbers have the same amount of decimal place values. Okay, for example, let me see if I can find one here. Yeah, there's one right there.
Mr. Tidwell, could you call 301, please?
53.24 plus 14.023. Okay, so if we line that up vertically, okay, that means 53.24, and then we have 14.023, and we're adding. Okay, what I mean by making sure they all have the same amount of digits is this one only has 2 at the top, so I need to add a 0 to it. That does not affect the value of the number. Okay, and realistically, when you're adding, it only holds a place value. There's really not any use for it, I guess is the word you'd use. It just holds a place value. Okay, when you're subtracting, I'll show you one here in a second where you're subtracting, and it does obviously have, use for it there. Okay, so now we just add it together. Okay, 0 and 3 is 3, 6, 2, bring down my decimal, 7, 6. 67.263. Okay. Now, let's look at one that is subtraction. Let's look at this one here. 168.42 minus 5.608. All right, I need to put a 0 up on top there. So now they have the same amount of digits. Both numbers have 3 place values on the right side of the decimal. Okay, and that's what we're looking for. All right, now we've got to subtract. So I can't take 0 minus 8, so I have to borrow 1, making that 10. 10 minus 8 is 2. 1 minus 0 is 1. Have to borrow from the 8, make it a 7, make that a 14. 14 minus 6 is 8. 7 minus 5 is 2. 6 minus nothing is nothing, obviously. And you have 162, 162.812. But once again, the decimals are lined up, and then the decimals brought down into the answer. All right, try this one on your own. 4.29 minus 3.456. Now, obviously, what's 3 minus 4? Or 4 minus 3, excuse me, 4 minus 3? 1. So your answer needs to be close to 1. Okay? Now, it may be a little less than 1, maybe a little more than 1. But if you get something like 10, well, obviously it can't be 10 because you're taking 4 minus 3. Okay, so use your logic here, logical estimation, and say, hey, this is what my answer should be close to. When you think you have the answer, raise your hand. Okay, Juliana, what'd you get? That's a 2. Do what? 836? No, not 846. What'd you get, Haley? 1.56. No. What'd you have? I have 1.256. No, not 1.256. Gracie? 0.834. Yes. 0.834 or 0.834. Let's look at it and see why. Make sure everybody's on track. There's your decimal. Then I put 3.456. Now, once again, I have to add a 0 to my top number. Yeah, you got to put the 0 up there, and that's subtracting. Borrow from that, make it an 8, make that 10, makes that 4. 8 minus 5 is 3. Borrow from the 4, make it a 3, make that a 12. 12 minus 4 is 8. Put my decimal, and 3 minus 3 is 0. Once again, just bring the decimal down into the answer. So 0.834. And that's your answer. Okay? All right, any questions over that? All right.